Well, let's operate with some common power series. Do you remember those three, actually four, power series that you memorized? I hope so. Let's just grab a piece of paper and write those three, actually four things down. Again, I say three, actually four, because there are four of them, but the three most common are these first three that I'm going to write. E to the x is the equivalent of the infinite sum from 0 to infinity of x to the n over n factorial. Good to know, good to memorize, right? That's our first one, very common. Another very common one is sine x, and if you forget it, don't panic. Keep in mind, one thing that will help you memorize at least components of this is the fact that sine is an odd function. So I'm going to need exponents that are automatically odd, like 2n plus 1, and my denominators are going to be odd, 2n plus 1, well, odd and then factorial. And we need this to be an alternating sequence. There we go. So we're going for some odds. So 2n plus 1. And 2n plus 1 automatically generates odd numbers. Plug in a 0, you get a 1. Plug in a 1, you're going to get a 3. You see where this is going. All right, the third is cosine, which is actually going to happen on the very first problem. And it goes from 0 to infinity. And cosine is an even function, and we know that from the graph because it is symmetric about the y-axis. By the way, sine is odd, as I just said, but it is symmetric about the origin, rotational symmetry. So we're going to have 2n factorial here. That's even. 2n up there. And then negative 1 to the n, because it is an alternating series. And then the last one that is not nearly as common, that doesn't really belong to the big three, would be this one. 1 over 1 minus x is really the equivalent of, from 0 to infinity, of x to the n. That's going to come in handy in just a few minutes. We're going to use that one. Now, these first three have an interval of convergence from negative infinity to infinity. This one does not. It's from negative 1 to positive 1. So we're going to hold this thought and use these as much as needed, which is about to happen right here. Number one, find a power series for f of x equals this. Okay, whoa, find a power series. If the problem just said find a power series for f of x equals cosine x, then mission accomplished. Like done, right? But it doesn't say that. It says cosine x minus this stuff. So let's just keep going. Well, f of x, let's bring our work over here, is really equal to cosine x. And cosine x is all this stuff that we just wrote. The more you write it, the more you'll remember it. X to the 2n, it must be even, it's cosine. 2n factorial. And then minus 1/2 and then 2 minus x squared. I'm going to distribute because I know where this is going, and if you don't know where it's going, it's okay. Just distribute anyway. So minus 1, and then plus 1/2 x squared. I'm going to call that x squared over 2. Okay, so you might be looking at that saying, well, what? I don't know where to go from here. I don't know what to do. Let's kind of expand this a little bit because we've done this before. You're going to see where this is really going in just a minute. Sometimes you just have to experiment. If I plugged in a 0, I would have, well, a positive and then a positive, well, x to the 0, which would be positive 1, positive here, and then a 0 here, which is 1. So I just have a 1. We're going to continue to expand this. How far are we going to go? Until we can smell the pattern. If we plugged in a 2, we would have a negative, and then it would be x squared over 2 factorial. I'm going to put 2 factorial because I feel like it. And I'm going to plug in a 3. When I plug in a 3, I'm actually going to get, when I plug in a 2. This is the 0th term, the 1th term, first term, 1th term. And this is when I plug in a 2. So this will be the second, well, n equals 2. Technically, this is the second term. I don't want to confuse what n is and what term I'm talking about, but anyway. Here we go. X to the 4th over 4 factorial minus x to the 6 over 6 factorial. You can see where this is going. And we're just going to keep on going with this thing forever. And it keeps on going until we get to the nth term, which we've already written a couple times. X to the 2n and then 2n factorial. And it actually keeps on going, right? And we just proceed until we get to this stuff. All right, now you might say, well, why wouldn't you stop here? Because it stops there. Well, it keeps on going because we haven't dictated in this line what n is. It goes forever. It's going to go forever and ever and ever and ever and ever. And then we get to this stuff, which is negative 1 plus x squared over 2. And this is where, when you do enough of these, you'll realize how amazing they can be when things just simply cancel. And we're left with this, which is basically this without a couple terms, right? So we don't start at n equals 0, and we don't start at n equals 1. We start at n equals 2, and we keep on going forever and ever and ever and ever. So what we really have is our final answer. It's the sum from not 0, not 1, but from 2 and forward. From 2 to infinity of this general form that's floating around kind of in the middle over here, because we have stuff before it, and if you want to continue the pattern, it would keep going after it, because it does go forever. X to the 2n over 2n all factorial. That is the first problem. The first problem was basically something I know minus something else. Now let's jump to the next one. Let g of x equal a binomial times something I know. And I want to write the first 4 non-zero terms of the power series for g of x centered at x equals 0, which of course would be a Maclaurin series. So let's do that. First of all, g of x is really this. It's x plus 2 times what? Well, let's pull this back out. There it is. It's that. And I'm going to write that step, although you may want to leave it off. So let's write this. From 0 to infinity of -1 to the n, and then we're going to deal with these odd exponents. Let's put that parentheses, and then 2n plus 1, and it's factorial. And you're looking at that saying, okay, I have no idea how to get from here to what they're truly asking, which is the first 4 non-zero terms. Well, actually, you do know how to get there, so let's keep going. I'll just keep going horizontally with this. X plus 2, and then let's start writing this. Plug in a 0. When you plug in a 0, you're going to get, well, 1x. When you plug in a 1, you're going to get x cubed over 3 factorial. It is negative. When you plug in a 2, you're going to get x to the 5th over 5 factorial. When you plug in, you can see where this is going. Now, by this point, it's going to keep going forever. And if you want to write the general term here, you can. But knowing where this one's going, and again, I know where it's going because here's what they asked. The first 4 non-zero terms. They did not say find the power series like this one. They said first 4 non-zero terms. I'm just going to stop it off there. If you want to write the general term out here, you can. But what I'm going to do, and I think this is going to be pretty straightforward, is this. X times x is x squared. X times x cubed over 3 factorial is x to the 4th over 3 factorial. X times x to the 5th is x to the 6th, over 5 factorial, minus x to the 8 over 7 factorial, right? And we're just going to keep going with that. How far do we go? Until we get the first 4 non-zero terms. Are these the first 4 non-zero terms? Actually, they're not, because here's what's about to happen. We also have to distribute the 2, right? So plus 2x, and then minus 2x cubed over 3 factorial, plus 2x to the 5th over 5 factorial, and then minus 2x to the 7 over 7 factorial, and it keeps going. Okay, they want the first 4 terms that are not 0, so we don't have any 0 terms here. And if we're going to list the first 4 terms, we're going to start with lowest exponent and then keep counting up. So here are the lowest 4. Let's just do this old-fashioned right there. This is all they're looking for. Don't circle that and pretend like that's your final answer, because we need to clarify. So the first 4 non-zero terms are 2x plus x squared minus 2x cubed over 3 factorial and minus x to the 4th over 3 factorial. that would be my final answer. And I want to put this in context. I'm reluctant not to say this all added together equals that, because it doesn't equal that. But this is the approximation. So I'm going to say that g of x is approximately that. That answers the question. They wanted the first four non-zero terms. They got them. All right, now it gets really fun. Let h of x equal sine x over 1 minus x. Find the fourth degree Taylor polynomial for h about x equals 0. Okay, fourth degree. When you're finished with this answer, you're going to have a highest exponent of 4, okay? First of all, look at what you have. H of x is sine x over 1 minus x. And I really hope you notice what is very obvious and then what's a little bit obvious. If you multiply sine x by 1 over 1 minus x, you would get this. My phone is ringing. Hello? Yes. Since it was a private conversation, I'm editing the video and I figured that I would just put a harmonica solo in. Here we go. Ooh, that's pretty painful. Sorry to leave you on that note. All right, let's get back to math, right now. Well, I just took the phone call and it was a mathematician telling me the best thing to do was to multiply sine x times 1 over 1 minus x. And I said, that's what I was about to do when you called. So they said, well, why don't you multiply the two power series together? And I said, you know, I was going to do that too right when you called. And he's like, well, I'm so sorry I interrupted you. I said, it's okay. It is not a problem at all. So this is what I'm doing. Going to do it anyway, but then they suggested I do it. So this is sine x right here, and then we're going to have 1 over 1 minus x. And again, I'm looking at this. Looking at this, if it's something you already have memorized, may not hurt to write it down. So times, we'll put a little dot there, and n equals 0. There we go. And then that's x to the n. And again, this only works for -1 to 1. That's the interval of convergence for that one. All righty. So let's write a few things out. When you write the few things out, you're going to realize the most practical way to attack this. So this series right here, let's parenthesize just for fun. Because the mathematician called and said, are you going to put parentheses? I said no, and then I changed my mind just now. There we go, we'll do that. This is really x minus x cubed over 3 factorial plus x to the 5th over 5 factorial, and then on and on and on. And then this one is really x to the 0, that's 1. X to the 1, that's x. X to the 2, that's x squared. X to the 3, da 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 da. And on and on and on it goes. Okay, so we want to find the fourth degree Taylor polynomial. So what we're going to do is multiply these strategically until we know we have guaranteed that we have the highest exponent of 4 and everything beneath it. So let's just do a few from the very beginning. So x times x, and this equals that. X times x is x. X times x squared, x times x is x squared, x times 1 is x times x is x squared. Let's get it right. X cubed, x to the 4th. Okay, there's that. And then it keeps on going. And then we'll have just a few more there. And we'll also have x cubed times 1. So that's going to give me negative. Let's change this to a negative. Negative x cubed times 1 over 3 factorial, and then minus x to the 4th over 3 factorial, and then there's 1 right there, but that's going to give me x to the 5th. That's going to be too much. All right, and then if we move on to the next one, we're going to have the x to the 5th times 1. Well, already we're a little bit too much, so there's that. And if we're going to put our final answer, we would say that h of x is not equal to, but is approximately. And if you put equals, I don't know, I'd be reluctant to do so because it's technically an approximation, is approximately equal to, now let's just write the fourth degree polynomial here. And when I do, I will have, I'm sorry, I'm looking back through my work, making sure everything's right. We're going to have x, that's the only x, right? That's the only x squared. And then we have x cubed minus x cubed over 6. That's 6. That is 5/6. 1 minus 1/6 is positive 5 over 6, x to the third. And then we have 1 minus 1/6, which is going to give me, again, 5/6, x to the fourth. Let's pause, make sure we're right. I think we are. We distributed the x as far as we needed to go. We distributed the x cubed over 3, the negative x cubed over 3, as far as we needed to go to get as many exponents as were necessary, as many terms as were necessary to guarantee that we got all the way up to the 4th degree. If you distribute that, you've gone too far. That is my answer.